Welcome everyone. In this video, we'll talk about how to find Taylor series representation of a function. So for this particular problem, we're going to write out the first three non-zero terms of the Taylor series representation of f of x equals ln of x, centered at x naught equals to 1. So we know that Taylor series representation of a function f of x is equal to the sum starting from n equals 0 to infinity of a sub n, but a sub n, we're going to find it as the f to the nth derivative evaluated at the center divided by n factorial. So this is how you get your coefficients. So sometime you might have seen it as cn or an, however, when you remember it, but that's how you get all of your coefficients, times x minus x naught to the nth power. So that is the definition. Now we're going to expand this sum. So the first term would be when n equals 0. So that's just the function evaluated at the center over 0 factorial, but that's 1. So this is just times x minus x naught to the 0th power. So that means you will not have this term right there. So it's just the function evaluated at x naught. And the second term of this series is going to be the function, first derivative of the function evaluated at x naught over 1 factorial times x minus x naught to the 1 power. Plus, the next term will be the function second derivative evaluated at x naught over 2 factorial times x minus x naught to the second power. Plus, the next term will be the function's third derivative evaluated at x naught over 3 factorial times x minus x naught to the third power. So you can write a few more terms, but I think this is good enough. You get the idea how the expanded form looks like. Now our goal is to find these coefficients. What is this one? What is this one? What is this? And what is that? Once we have them, we have a representation of Taylor series representation of this particular function centered at 1. So our x naught is given is right here. It's going to be 1. So I am going to sub in 1 right here, 1 right here, and then 1 here. So all of these x naught, we're going to replace it with 1 for this particular example, since it is given. So if you were to write out a few more terms, so this is the function evaluated at 1 plus the first derivative evaluated at 1 over 1 factorial x minus 1 to the 1 power plus the second derivative evaluated at 1 times x minus 1 to the second power over 2 factorial plus the third derivative evaluated at 1 times x minus 1 to the third power over 3 factorial. So I'm going to write, you could write more terms, but let's hope this is good enough. Now let's go ahead and find these coefficients. So we're going to compute the derivative of this function, f of x. So let's find them. So the first derivative, it's going to be, so we know f of x is given as ln of x. And the first derivative, we know that's 1 over x. And now you're going to evaluate this at the center so that you get the first derivative at 1. So that'll be 1 over 1. That's 1. So that's what we're going to plug in right up here. Now, the next, we're going to compute the second derivative of this function, the second derivative of f of x. So that means I'm taking the derivative of this. That's going to be, so you can bring the power up as x to the negative 1 power. So that's negative x to the negative 2. So that's, we can write it as a positive exponent as 1 over x to the second power. And now we're going to evaluate this at the center, which is 1 in this case. That's negative 1 over 1. That's negative 1. So there you have. So that's what we're going to plug in right up here, divided by 2 factorial. So that'll be the coefficient A2, if you remember it that way. Let's keep going. Now let's go ahead and compute the third derivative of f. So that's going to be, so again, you can write this as x to the negative 2 power. So again, using the power rule of differentiation, you'll have a positive 2 over x to the third power. And then evaluate this at x naught equals 1. So you'll have 2 over 1 cubed, that's 1. It'll be just 2. So our third derivative at 1, it's going to be 2. Now we're going to plug these coefficients in here. So that's going to go over there. And we also need to plug in what this is into our function. So the first coefficient is the function evaluated at the center. So this is ln of 1, that's 0. So that's why we're going to plug in this one. So let's go ahead and plug these in. So we got the value for this, this, and that. So we're going to go ahead and sub them in, and we have our power series representation of ln of x at 1. Now, if you remember, we wanted the first 3 non-zero terms. Now, since this one is 0, that doesn't count as a term, so that's why we needed to go for a few more. So these will be our first 3 non-zero terms, since they do have non-zero coefficients. So let's go ahead and write this out, and then we are done with this problem. So I'm going to just go ahead and put this infinite sum right here. And we know the left-hand side is ln of x. So we have ln of x is equal to this infinite sum. So f of 1, we know that's 0. So this is 0. F prime of 1 is 1. So that's what I'm going to put right here. And then f double prime at 1, that's negative 1. So I'm going to put that right here. Divide that by 2 factorial. And the last non-zero terms we have is this guy right here, the third derivative at 1. So that's going to be right here, 2. So there you have your coefficients. So then we can say that ln of x is equal to 1 times x minus 1 minus 1 over 2 factorial is 2. So you can just write that, x minus 1 squared. The next non-zero term is 2 over 3 factorial. So I'm going to keep in factorial form, x minus 1 to the third power, and so on. So we had to write all the way out to the third derivative because f of 1 was 0. So that doesn't count as a term. So this is our answer. The Taylor series representation of ln of x centered at 1 is this. Okay, I hope you enjoyed. See you next time.